there should be remediation approaches for treating system when it's compromised, and also there are some other aspects in relation to the compliance and regulation. How we, I mean, in terms of the data governance, for example, which is usually affected by the compliance and regulations in the organizations and government agencies. So the security has two different views for IoT: inward security and outward security. So inward security means the potential harm to the health and safety and privacy of device users and their properties, both in internal users and devices. And outward security is obviously about all the devices and systems which are outside the network, whether they might be affected as well. So we need to look into both inward and outward security. So there are lots of security issues. There are, I mean, unfortunately, there are very small number of companies who are feeling confident in securing IoT devices against attacks, and 70% of people, according to some surveys in the society, are very or somehow concerned about the security and privacy while they use IoT. And that's a top concern for IoT developers and users. And it's only possible to promote this technology if we can address all these concerns of the IoT systems. So there are some issues that I'm just going to have a quick look at them because there's not much time to go to details. But basically, issues are categorized into different things. One of the problems about single point of failure, you might ask, okay, the system is distributed, it's decentralized, we have billions of devices. Why there is single point of failure? Because we have also central processing systems, and we have some systems which are collecting data and processing. So there might be problem of single point of failure. Also, sometimes we ease the access to data, we facilitate users' access, and we compromise the security and privacy in the systems. That's downgrading the security and privacy level of the system. That's another issue. There's lack of a standardization. That's the biggest, one of the biggest problems. There's no standard protocol. There's no standard way of building IoT systems. So there are many different technologies nowadays, but it's a work in progress. It might be something very standard in the future. Frequent changes, limited resources, another issue that we have very small devices, very small processing power and energy. So that's a big problem for adopting some technologies to accommodate security problems. And many other issues, as you could see here, and the scale of data, as I mentioned before. So the attacks which are actually happening in the system might be in different layers: application layer, middle layer. So I showed you the architecture because my intention was to show you that that architecture with different layers, that might be affected at different layers by different kind of attacks. And you can see here, so at the application layer, we have some kind of attacks in middle layer, middleware layer, network layer, and device layer. So these attacks are happening at different layers. Some of them are common in multiple layers. I'm not going through this because, yeah, so each, but just an example here. Distributed, the denial of service attack is one of the very common attacks which is happening in many different kind of systems, and it also occurs for an IoT. And distributed denial of services, again, as kind of a more kind of expanded version of DOS attack, which is very common for IoT. And the problem is that when a victim node is compromised, the hacker could do anything. They could get access to data, they can steal data, they can do eavesdropping, and they can also implement some other kind of attacks, one after another. So there's a security vulnerability in the system that's opening gate to the hackers, and they get access to the system, and they they can implement different kind of attacks in the system. So there are different kind of solutions. Again, I'm just going to kind of just touch base on this. I'm not going through details, but basically in terms of the solutions, we are looking for something distributed. By the nature of IoT, we have a distributed, decentralized system. So that's why blockchain, which is distributed ledger technology, could be an option. And also there are nowadays some other versions of the distributed ledger technology like Hashgraph or a few others. So there are also some like potential candidates for improving security for IoT. But the problem is that if you want to use blockchain, blockchain requires mining operations, which are computationally expensive. So if you want to implement these computationally expensive algorithms on these little devices, that would be a big challenge. That's again is work in progress, and many people are working on it. I'm also part of my research is about this. So today I don't have any results to show you about that, but this is one of the areas which is very active research area in the IoT domain. So the problem is that IoT devices have limited processing power, and blockchain is computationally expensive. So it's not really straightforward to adopt blockchain in IoT. And another idea is like decentralized and private by design IoT. When you basically implement security on the basis of peer-to-peer network nodes. So between each peer, you make kind of authenticated and secure data transmission, and you even store sensitive data on every single node just to make sure that your data is secure. So this is kind of authenticating all data operations. And obviously data governance and access policies are very important here. When you're setting up your network with peer-to-peer connections, it should be clear who is going to access what in the system and at what level. And another idea is to use software-defined networking for people who are working in software areas. So this is one of the interesting areas. So it's about using software to control network. Instead of admin people who are doing lots of configuration things, you can write a few code snippets and scripts to automate the control of the network. And this software-defined networking could be also used for improving this enhancing security in the system, and also blocking some attacks which are happening very frequently in the system, because your system is getting smarter, so it can detect some of the attacks which are occurring and then avoid them for similar scenarios. So the information could be logged and also shared with others. So one of the key things here is that we need to be very collaborative and cooperative if we want to enhance the security in the system, because we need to share the information about the attacks. There are some emerging attacks. Hackers are getting smarter. They're using the different new techniques, and they're finding out new vulnerabilities in the system. They're trying new kind of attacks. So that's in a very cooperative way. If this information is shared, that would be possible for people to avoid this in the future and find some solutions to. So the last thing is about incorporating security into development life cycle. So if we have kind of upfront planning for implementing security in the system from very beginning to the end, from design and analysis phase up to the implementation, deployment, testing phase, if we can do this for software, for example, which is going to be used as part of IoT, that would be a big thing for the system. So it should happen at every single phase to make sure that our system is not going to be easily compromised with very kind of silly vulnerabilities. So the last thing, just to wrap up this discussion, is just a few points about what I said. It's about developing some algorithms and models to analyze and diagnose, trace attacks on this. We need efficient and more effective models to be able to do this. And obviously data is very important here. We collect data, we can analyze it, we can better understand the type of attacks which are happening in the system. And lightweight self-healing capability in thin devices, instead of small devices. We can have an efficient, like some of you are going to probably present about different kind of cryptography algorithms, encryption, decryption, but these should be kind of efficient, and they should be customized for these little devices. And extensive security assessment of the platform, continuous monitoring, auditing, and detecting emerging threats on different layers. Security, like embedding security capabilities into like different stages of the life cycle of the IoT system. Establishment of the trust is very important, maintaining that trust between the peers. When there is a communication happening between two peers in the network, there should be a trust establishment, and there should be also automated trust management in the system. If whether or not IoT involves cloud, very heavily, a cloud is involved, engaged with the IoT. So it's important to understand that how cloud is going to protect connections, provide a kind of secure resources, and how it's going to implement authentication and all the computation storage. Effective interaction with different other systems is also important, with third parties and other things, which is requiring some standardization in the future. Strong policy controls and data governance, which is very important. Proactive and pervasive security controls. Being proactive is very important, not just reactive or passive. And inside and outside the network, as I said, there are two different views. And finally, user education. As we all know, the biggest problem in the security of the system is the users and human factor.
Professor Farhad, we are running.
Okay, sorry, yeah, I'm done. Yeah, sorry.
Dr. Farhad, the time is running for you.
Yeah, okay. I'm done with the presentation.
Please finish your talk. Dr. Farhad?
Yes.
Do you hear me?
Yeah, I can hear you, yeah.
Okay. You are running to end of the talk.
Yeah, that's the end of the talk, yeah.
Yeah, that's the last slide.
Okay, thank you.
Thank you, Professor Farhad, for your comprehensive talk about the security of Internet of Things.
Thank you so much.
We open for discussion. Any questions?
Dr. I have one question about the Professor Farhad mentioned.
Dr. Ayman, yes.
Two solutions in the end of this presentations. Use blockchain in IoT. This is a decentralized approach for security. How to implement in IoT devices, live devices.
Yeah. As I said, that's a major challenge for implementing blockchain and IoT. But there are some solutions, just to make a lightweight version of different kind of, cryptography hashing algorithms.
Yes.
And also, I mean, it could be done at different levels, but and that's a work in progress. So as you might know, there are some papers already published on that, but there are also some other alternatives for blockchain, like Hashgraph or other distributed ledger technologies, which could be more suitable for IoT case. But this is just an example to show that the decentralized system could be helpful for making IoT, which is by nature very distributed and decentralized, more secure.
Okay, another one, software-defined network. This is an approach for the network that separates the control plane to data plane. How to implement in IoT?
This
one.
So
to return into a centralized approach. Control. Software-defined network come back to centralized approach.
I think that you have to go to the network layer to apply software-defined networking.
So software-defined
You have
networking, the control plane,
physical layer, and you have the
the-
data link layer, and you can apply it on the networking layer.
I think it could happen at both networking layer and other layers as well. But basically, as Professor Zekri mentioned, so it could happen at networking, but the application layer as well, because you are going to control the system and the network, right? So with the network administration, everything which is possible at the network administration, you could automate it with the software-defined network. And for the IoT, you can have better control on the system and the communications over the network.
Yes, I have a question.
Yeah.
What is the most critical issues for securing Internet of Things? The most critical points. Can one use the ES algorithm, for example, and it will be sufficient to secure the Internet of Things?
No, the idea is that, as I said, the security should happen at different layers. It's not just possible to make the system secure at one layer. It should happen through all the, like what I said in the IoT architecture and the middleware, because the threats and vulnerabilities exist at every. Another big thing, I think, from my point of view, is the human factor. I think this is opening lots of, creating lots of vulnerabilities in the system. The user should be educated, because these little devices are spread over the, all over the place, and people are using them. If we just want to facilitate the way that users access data and use these devices, that will compromise security. Whatever security that you provide in the system, that will be compromised. It's a very simple mistake. So the user
that they are very widespread overall, so that securing them will be a very difficult task.
Okay. Obviously, that's why IoT security is a top concern. It's not a simple issue like security.
Thank you, Professor Parad. Have we any other questions?
Professor Halim, we have 3 questions. I think Professor Koji raised his hand. He has a question, I think.
Okay, Professor Koji.
Yes, can I ask
Yes,
question?
Professor Koji.
Hi, Koji Sensei.
I don't see him.
Thank you.
How are you doing?
You can manage, Dr. Ahmed.
Thank you very much for your very interesting talk. So this is a question from Japan.
Sure.
I think I would like to ask about your opinion of the trade-off between the security and the cost, because IoT system, the cost constraint is really hard. So but on the other hand, we have to pay some money for security. But if this is very expensive, nobody will apply such kind of security. That becomes very dangerous. So what do you think about how we can solve such kind of the difficult trade-off between the cost and security?
I think this is a problem for every other system as well, right? So you always have this trade-off. We need to make a trade-off between cost and performance. And also, security has some other dimensions. For example, about the availability, right? Like confidentiality, availability, and integrity. So you have also the same trade-off there. You compromise the performance just because you want to make your system secure, right? So the cost as well. So that's a trade-off. We need to see for what kind of application we are going to use it. If it's going to be like for an industrial or mission critical situation, obviously security is very, very important thing. Probably we need to spend more money on that. And if it's for some other applications, it would be probably different, right? So we need to look at our system constraints when we are designing that and implementing that.
Okay, thank you very much.
Thank you, Professor Koji.
Yep.
I think that we have to end this talk because we have other 3 talks.
Professor Farhad, there is a questions in the chat. You can answer.
Yes, there is a question that said, what is the role of artificial intelligence on future security systems?
Okay. This is a very good question. Yeah. As I said, one of the key things is that these systems are intelligent and smart. They're part, like IoT is just to build smart systems, smart cities, smart infrastructure. So So AI and machine learning is playing a very vital role in it, in different stages of building system and also utilizing that. I think one of the key things, we use IoT to collect data, to process, analyze it. So analyzing data without machine learning is meaningless, right? So you need AI and machine learning, and you have big data. So you have extensive amount of data. So you need to use some machine learning techniques. Even sometimes you have to go for something like deep learning. Then you have very, very complicated data. So it is playing a vital role, and obviously it's undeniable, which is that AI is very important for IoT.
One last question, I think, from Hana Shakir. What about using biometrics in IoT systems? And what about employing artificial intelligence and deep learning techniques?
Yeah, I think I answered the second part of the question about the biometrics. Yeah, obviously that's part of the IoT, right? So you can put lots of different kind of things. It's basically about things, right? So and well, as Cisco says, important things. It's about connecting biometric devices. I'm not sure exactly if I'm answering this question, but if you mean that in terms of the devices and things that we are going to use in IoT, yes, it is. As variable devices, you know, we need variable devices to get connected to the network, right?
Yes.
Yeah.
Yes. Thank you very much, Professor Farhad.
Yeah, sorry, just one more thing about biometric things. But for security purpose, yes, that's another idea for security purpose. Yeah, obviously for authentication, for authorization, and other things. Yes. Yeah, thank you so much, everyone. My presentation was longer than expected, but I appreciate your time. This is very late night here. It's around 1 a.m. So I'm just going to bed. So I have to say goodbye to everyone. Yeah.
Thank you, Professor Farhad, for your interesting talk. And we end this talk, and we started the second talk. Professor Ayman, go on, Professor. This is your role. Introduce the next one.
I think Dr. Reham Tariq will be the presenter. So Professor Ayman, you can start. Just unmute, Dr. Ayman, unmute the mic.
Okay, now I can present the next papers and AODD-based routing schemes for large-scale Bluetooth low-energy mesh network. These papers, the speakers can take 50 minutes to present the paper. 15 minutes. Okay, 15 minutes to present the papers and then the discussions and the questions. Okay, go on.
Yes. Dr. Reham, you can start. Introduce yourself first, and then you can start with your presentation.
Okay, so can you hear me?
Shortly,
is it clear?
Shortly, please.
Okay, so first I'll introduce myself. I'm a graduate from the Faculty of Engineering at University. I have a bachelor's degree, and the rest of the authors are also graduates. We all have bachelor's degree in electronics and electrical communications engineering. And let me introduce this work. This was first started as a project in Cairo University, and it was supervised by Dr. Khaled El Sayed and sponsored by SciVision. And then after we obtained some pretty good results in it, we thought it's a good idea to transform it into a scientific paper. Okay, so let me start with it. Here I'm trying to give a very abstracted view of the work so that I can explain the main points and the main idea behind the work, and also the problems and how the performance turned out to be. So briefly, as an introduction, what is this work for? As the name suggests, it is a routing protocol that is suggested for Bluetooth Low Energy Mesh networks. As we know that Bluetooth Low Energy is a very interesting topic, that it has a very wide market in the IoT field. So the Bluetooth Low Energy has a standard called the mesh networks, which enables the many-to-many connections between them. So first, what is Bluetooth Low Energy? Bluetooth Low Energy is a variant from the classic or the well-known Bluetooth Classic. It is optimized for low power consumption, so it's widely used for the devices that require very low cost and very low complexity. So in BLE, we have two methods of communication. We can either broadcast messages or create connections. And here comes the Bluetooth mesh, or the standard that is specified by the SEG, or the entity that creates the standard, the BLE standard. The BLE mesh enable this graph, or this how can Bluetooth devices can connect in a many-to-many topology. And that was a very breakthrough because it enables a lot of areas for the IT field, especially, for example, the wireless sensor networks, for example. It's a very wide area, and we can connect it with a protocol that requires very little power, like BLE. That's a very good advantage. So let me just get the slide back. Sorry. Okay, so what's the problem with the current Bluetooth implementation? As we said, that we have a standard called the BLE mesh that enable this kind of relationship. But the thing is how the messages are being sent inside this protocol. So let me just define the problem here. If we said that this node wants to send to this node, it basically what it does is that it floods the network with packets. And when it floods the network with packets, the packets keeps propagating to all nodes, and all nodes relays all nodes until we reach, I don't know why. Just keeps, sorry. Okay, so all nodes just keep relaying these packets in here, and we have a lot of congestion inside the network. So we thought we can further improve this work, and we can have a better network with less congestion, and we have a network that is not very overloaded with packets. So here's the problem statement again. This is the flooding case in which a node wants to send the node. This errors represents that all these are relayed packets. And here we thought that we can further improve the standards by adding the routing functionality into it, so that we only have this kind of two errors, which means that we have very less number of transmissions. So what's the routing protocol that we build our base on? It's the ad hoc building protocol, which is an EUDV, an already existing protocol. We took the very base out of it, and we added new messages, and we adjusted it to the existing mesh network. So the idea is that we already have an existing standard, and we have very, very great features that are very helpful for the IT industry. So we wanted to make use of them. Again, I'm sorry. Okay, so we wanted to make good use of them. So that's why we wanted to add this protocol and tailor it for the mesh standard. So let me quickly explain our proposed design. So for our proposed design here, we have 4 main components that we developed inside our paper. We perform a route discovery and a route selection, data forwarding, and route maintenance, and we'll discuss them in details. So for the routing table, for every routing protocols, we have a routing table. This is the structure of the routing table we implemented, and this is some of the fields are for the already existing standard. Some of the fields were tailored for the new mesh standard, and some of the fields were actually added by us to make the best of the network, and we can have the best route selection and so forth. So we tried to add some graphs. Let me just go ahead and this is a graph that can further explain, just to limit the time. What do we really do in our routing protocol? In our routing protocol, we want to select a path. So we have 2 main messages that we use. We have a route request message and a route reply message. When a node wants to create a route, it starts sending a route request message. And when the route request message is received by the destination node, it sends a route reply message. That's the very basic thing, and that's the basic idea behind the EUDV's selected protocol by us to enable the route selection. So here we can create, through using this protocol, we can create some bi-directional routes that can be handled inside the mesh network. So back to our routing table. This is the entry for the routing table. And as we see here, we can have, we have addresses that we need. We have some tables that are related to the mesh network, and we have two fields that are related for the route selection. Let me first discuss what is the route selection. In our algorithm, we wanted to make sure that we have the best route selected for the network so that we can have the compromise both the shortest path and the best route. That is ideal for the transmission. For example, we wanted to pick the best RSSI and we want to pick the shortest path. So our metric depends on both the RSSI value that we obtain and the number of hops. Okay, so that's basically what the node does. What the node actually does when it starts to searching is that it uses a technique called the ring search technique, which means that if a node S wants to search for a node D, it just searches for the neighbor nodes. And if it's find destination between neighbor nodes, it creates a path with it. But if it did not find, it keeps searching and incrementing the circle. So we choose this technique inside our work so that we can limit congestion, because that's the very basic point that we want to achieve. That we want the best. We want to limit the number of packets as much as possible to ensure that the network resources are used in its best method. So this is a structure of the route request message that it's being sent for to create the routing table, as we discussed. Of course, it's had some fields that are taken from the AODV and some fields that are tailored to express the functionalities and features that already exist inside the mesh standard, and some features that added by us to further optimize the network and take the best of it.
منبه يا ماما. منبه عندكم منبه. هاتي المنبه اللي تحت.
Sorry? Dr. Ayman, if you're talking, the mic is muted.
Sorry, Reham, you can continue. I think it's
Okay.
unintentional mistake, no problem.
Okay, no problem. Okay, so to further try to do some optimization inside that network, we had some new messages that we created for our protocol. Some of these messages are called the route weight message. The route weight message is to, for the route selections, we wanted to, as we are going to see here, we wanted to send the least number of packets that we can. So for example, here, let's say that we have a node X that has an already established path to a node D and a node S that wants to establish a path with node D as well. So when we send route requests, we keep flooding the network with these route requests, but we don't want to do that. We want to limit the number of route requests that is flooded inside the network. So if node X here has an already established path, it uses the path that it has so that we don't have to flood this part of the network with route requests. And we send this message, the new message, the route weight, to the path back, such that we can create a route inside our network with the least number of flooded packets as possible. Okay.
Mr. Ham, I think we have only 3 minutes to finish.
Okay, yeah, I'm going to wrap up really quick. Okay, the very last feature we have here is something called the route maintenance, expressed in two messages, the hello messages and the route error. And we can see in this visualization that for each established route, we have nodes that make sure that all nodes exist. For example, if I have a path with node B and node E, I want to make sure that node B and node E exist. So node B and node E keep sending these hello messages to just let other nodes know that they still exist and they are still running. So these routes are still valid. So what happens if a node does not send this hello packet? As we see here that the node S does not receive the hello packet and detects that there is a route breakage that happens. And then it informs the paths that this route breakage has happened, and we can no longer send to this destination, so that we can have a reliable and robust protocol embedded into our network. So we will not send the packets unless we know there is actually a path to this node. So this is how. Let me just discuss the results to know if this worked worth the hassle. We made this very pretty setup.
We have 1 minute, please. Sorry, so we can fast, please.
Okay. We made this setup. We had some nodes that are connected to a laptop, and we have a local server that aggregates the data, and GUI that prints out some statistics to see if our work really did some improvements. We have this case scenario, 5 nodes sent into a single node. So we wanted to flood the network with packet as possible and see if routing actually did make the change. We here see the throughput curves, that we see that a very nice curve for routing, because each node that starts to send packets, we see that all packets are almost delivered here. But in case of flooding, we see that there's a lot of packet lost in a very unstable packet, which means that this routing protocol has actually improved the throughput received by the destination node eventually. We tried another case scenario for letting only one node sends the data and see if we can further optimize how the traffic is inside our network. And we see that for the flooding case, we had a very high traffic in all nodes, because all nodes here inside our scheme relay nodes, but for routing case, we only have 3 nodes that relay. So we have less traffic inside our network. So this is my last slide, and this is how, this is the downside for both cases. We have a very high packet redundancy in case of flooding, because we have a lot of free transmissions, because the network does not have a dedicated path. So it keeps, all nodes keeps flooding the network until it reaches destination. So as we see here, it's almost 66% of redundant packets. While here in the routing, we can see that the overhead is much less and has a very little percentage compared to the flooding technique. And this percentage actually decreases with time, because this redundancy is only represented in the control messages explained earlier to create and set up the paths, and the hello packets that we said that the messages keep sending. But as we see, it's clearly a relatively less percentage of redundancy in the network in case of routing than in case of flooding. Okay, I think it's I'm almost done here, and I'm open for questions.
Okay, thank you, Dr. Raham. Yeah. Any questions for the guys? Ahmed?
I have no questions. Professor Abhalim. Open the mic, Professor, please.
The mic is mute.
Okay, it's on now.
Thank you, Dr. Raham, for your very interesting talk about routing in ad hoc low energy Bluetooth networks. My question is, can you improve the performance than your algorithm in the future?
Yes, we have a lot of
you have still about 28% that is consumed in routing.
Yes, exactly.
Overhead.
Yes.
Can we reduce more this percent?
Well, this 30% was after adding new control messages and optimizations, and for using already existed routings, and for adding many functionalities that actually reduced. It was not the 30%, and we added these messages to decrease it to 30%. But to reduce it further than 30%, I think that will require some new functionalities to be added to routing algorithms, such as new control messages that can repair. For example, if there's a packet that, if it's a link that is lost, we can repair it instead of flooding the network again with root requests. We can have like some data about like paths in the past, so we can reuse them in creating the new paths. We can do some new more methods to further improve it in the future.
Thank you very much. Is these results are also applicable for large networks?
Yes, this was first, this is a prototype just to make sure the idea is very efficient, and it was initially designed with the large network scale in mind, because we wanted, when we first drafted this protocol, we was always thinking how this can be done inside the large scale networks. So this basically was developed to scaling this to a large scale.
How large was your network?
My network.
How many devices?
the testing network has 6 devices. That's the devices, and we created a connection that we had these devices to just do as much congestion as we can, just to mimic that. But we didn't go further than 6 devices. That's the that was a resource limitation for us when testing. So it was a prototype with 6 devices. But I think it's a future work for us to run this prototype in a demo or in a simulation tool that can simulate nodes, very large number of nodes, and see how much this protocol can improve performance than the existing routing protocol.
Okay, thank you, Dr. Ham, for your answer.
Okay, Dr. Ham, I have a question, assembly questions about when you compared flawed network and rooted network. Sure, rooted network is better than flooded on overhead or control message, etc.
Yes.
There is another routing to compare your proposed with it.
So your question is basically if there's another routing protocol that can exist on top of mesh that we can compare our protocols with. Actually, no, there's not. There are actually other routing protocols, but they were not designed for mesh, for not PLE mesh. This was the first protocol that we can design to work on top of the PLE mesh and use the already existing functionalities over mesh. So there's not an already existing protocol for PLE mesh, but there are protocols that we can try to port it and see if it can have better performance or not.
Okay, but you compared with flooding.
Flooding is an already existing technique.
Time, yeah, Doctor.
Yeah, flooding is the already existing technique inside the PLE mesh standard. So that's already existing in the standard, but they don't provide routing. So we added the new functionality of routing.
I have to take care of time.
Took care of time.
Okay. I think I'm done. Okay.
Thank you.
Yeah, thank you.
Okay. Thank you.
Doctor, thank you, Dr. Ayman. And Dr. Ahmed, this is your role. Please go on.
Okay. I would like to welcome Mr. Ahmed Abbas, or Dr. Ahmed Abbas. I think you can mute himself. Okay, the paper, he will present the paper number 9.
I'm ready.
Okay, Simulink-based modeling and performance analysis of NB IoT uplink scheduler.
Yes.
The floor is yours. You can start your presentation by presenting yourself in 1 minute, please, and then start your presentation. I hope you stick with the time, 15 minutes and 5 minutes for discussion. Thank you.
Yes, okay.
Are you hearing me?
Yes.
Yes,
okay.
Everything is good. Okay.
Bismillah ar-Rahman ar-Rahim. First, I would like to introduce myself. My name is Ahmed Mohammed Abbas, lecture assistant in Egyptian Atomic Energy Authority and JAC, and the PhD student in Electronics and Communication Department in Shamsi University. The title of paper that I will be present is Simulink-based modeling and the performance analysis of narrowband uplink scheduler. The co-author team, Professor Dr. Abdul Halim Zikri, Dr. Khalid Youssef, and Professor Dr. Mbabi Ismail Mahmoud. Our outlines, overview, problem statements, objective novelty, and the contribution that the paper will present, a model architecture, performance evaluation results, conclusion, and finally future works. Internet of Things applications are considered as key digital transformation enabler for several industries and utilities, including smart cities, factories, and power grids. Compared to other low power wide area technologies, narrowband IoT achieved unrevealed low power wide area performance in terms of coverage, variety of data rates that can be supported, and deployment scenarios or operation mode that will be discussed in the next slides. Therefore, to cater the massive IoT requirement, the 3GP has standardized that the massive MTC services will be served by further evolving narrowband IoT as integral part of the 5G specification. The problem statement. This paper addresses two problem statements. First, narrowband IoT modeling methodology and the performance of the narrowband IoT at the difference that as the 4 different data rates. The first issue. The analytical methods accuracy require high. First, we have 2 modeling strategy. First is the analytical methods that use mathematical computation or mathematical theories, but it require a high degree of complicated mathematical equations. It doesn't consider the impact of the other layers. Another strategy is the Simulink or the simulator platform, such as in S3 and OpNet, which require a sophisticated interface with other tools, such as MATLAB scripts, to execute their KPI calculation statistics. Moreover, the OpNet require lots of complex configuration at platform installation and before running the simulation. Also, OpNet license imposes many limitations. And recently, OpNet exploited the Simulink feature itself, in other words. Recently, the MATLAB release 2017 platform prepared narrowband IoT scripts that models only the 5 layer of narrowband IoT for only 10 millisecond snapshot. The second problem statement. Each narrowband data rates characteristics were not studied enough from the aspects of each IoT traffic profile of the different IoT application type. I mean, analyzing the narrowband IoT performance with aperiodic, or real-time traffic. Moreover, most literature on the efficiency optimization techniques didn't elaborate on the chosen optimized data rate criteria. The objective of our paper, build and model for the narrowband uplink scheduler as a part of a complete narrowband protocol architecture project. Second, we will employ this model to evaluate the narrowband IoT uplink scheduler performance. The novelty of our paper, for the first time, the model is completely built using the state machine modeling methodology over the state flow toolbox of the Simulink environment. The narrowband IoT uplink scheduler performance evaluation consists 4 different narrowband IoT data rate to study the performance metrics for each data rate. Our contribution help researchers and developers to build, study, and develop IoT 5G network models for more details and scalable with easier way and the faster way using the most familiar development platform, such as Simulink. Second contribution, highlighting the data rate choice criteria for IoT traffic model type and pros and cons for each choice. First, before go on to our architecture or our model, I will give a small brief about a narrowband IoT characteristic, the main characteristic. First, the narrowband IoT is globally is standardized from 3GP standard. This technology is a modified design of LTE that aim to serve the IoT traffic only. Also, and according to this modification, the narrowband IoT can provide enhanced coverage compared to LTE. The most LTE modifications to design the narrowband IoT concentrated in the physical and MAC layers. Its operation mode, standalone mode, which utilize the 200 kilohertz band of GSM band, in-band mode, which utilize the LTE resource block, at least 1 resource block, the guard band, which exploit the guard band of LTE bandwidth. The 5-layer characteristic, the small, as we mentioned before, the smallest bandwidth for narrowband IoT is 180 kilohertz for uplink or downlink. Adopt the same multiple accessing technique for uplink and downlink. Use only ordinary cyclic prefix of 7 samples per time slot. The modulation scheme was reduced to binary BSK and QPSK, binary BSK or QPSK, operate on the half duplex scheme only. It's uplink channels, only two uplink channels, one for random access and the other channel for control messages and data. The McLear characteristics, the downlink scheduling is over 1 subframe, 1 millisecond. But with respect to the uplink scheduling is per complete radio frame of 10 milliseconds. The buffer status report type is short and regular. The data radio link is released either by the base station receive BSR equals 0 from IoT terminal or after timeout of non-receiving payload from the terminal. This release determined by release assistant indication activation during the RRC connection setup message. Our model based on the 3GP standard release 14. The left figure represents the message sequence chart for 3 phases: random access phase, RRC messaging phase, and scheduling phase. We modeled these phases in the right figure by 4 main super states. The first and the second message modeled by the super state number 1, random access phase. The messages from 3 to 5 modeled by the super state number 2 are messaging phase. And the message number 6 and 7 modeled by a super state number 3 and 4. Number 4, super state number 4 for LED data scheduling, LTE resources. We considered it for 2 things in future work, and also if we would like to model real-time traffic such as video traffic. The right figure represent the McLear state machine for E node B station with respect to the UE node is modeled with only 3 super state, and each super state has substates.
You have 5 minutes.
Okay. Then we model the periodic, the IoT terminal. In this phase of our project, we model the periodic profile. We consist of two main super state. The first one responsible for traffic density increment and initiation. The second super state responsible for payload size and transmit the payload after receiving RRC access. This is our KPIs: resource utilization KPI, channel holding time, RRC setup success ratio. This is simulation, setup, and validation. We modeled, we validated our model according to other model used NS3 simulator. Except the difference is the duration of our single simulation runtime is 1 second. We divide the E node B bandwidth 20 megahertz equally in the four data rates. This is our result analysis. The first one, the number of IoT terminal versus utilization, and we conclude that the single tune achieves the highest resource utilization. The second KPI is the channel holding time. Also, the narrowband achieves the highest channel holding time. And the third KPI is the RRC setup success ratio. Also, we note that single tune can serve the maximum possible number of IoT terminals with 100%. Our conclusion, according to current standard, our simulation result proves that narrowband IoT single tool achieves the highest utilization and traffic density served. The single tone data rate is the optimal choice for periodic IoT application, but at the same time, the narrowband single tone achieves the highest channel holding time. This result may indicate the degree of utilization of network resources with peak time. It also indicates that the single tone channel was holding all this time to single UE to transmit its payload. This issue causes poverty in network resources later on. So this left the door open for optimizing the narrowband IoT spectral efficiency. Our future work will consider the propagation and with different traffic distribution in this model. And we will optimize the narrowband IoT spectral efficiency at different propagation and the traffic distribution characteristics. Thank you for your good listening.
Thank you, Mr. Ahmed, for your the presentation. I open the floor for questions. If anyone has questions.
Okay, I am ready.
I have a question from Dr. Hana Shakir. Narrowband IoT introduces interference to LTE. How did you deal with this problem?
Please, again, your question.
Narrowband IoT introduces interference to LET. How did you deal with this problem? Okay.
Narrowband IoT is already a modified version from LTE, and in the bandwidth allocation is allocated specific radio resources. So the interference issue
not present.
Not present, yes.
There is no, excuse me, Dr. Ahmed. The Internet of Things operates according to LTE standards. And so it shares communication resources from LTE. So there is no collision or there is no interference between Internet of Things and the whole LTE network. Thank you.
Any other questions? Professor Ayman, do you have questions? Please unmute your mic, please, Professor.
No, thank you. Thank you.
I have one last question about the results. Are these results generated from the model compared to any published work, or this is the model results, your model results only? And how you verify these results according to the literature?
Okay, this model is verified and validated with other model or other work modeled by NS3 simulator. The benchmark result is resource utilization.
Network simulator under Linux.
Yes.
Yes.
And we used the benchmark of the NS3 simulator.
Okay, thank you.
Dr. Ahmed, would you plot these results of NS3 on your graphs so that the comparison will be shown on your figure? تحطها يعني. النتائج.
It would be nice to have the results of the literature with your results for comparison.
Yes.
You mean the benchmark?
The question of Dr. Ahmed is very good question. Thank you, Dr. Ahmed.
Thank you, Professor.
Okay.
Dr. Ayman, you can present the next paper, please.
The next paper, the last paper, okay?
Yes.
I will present the last papers. The title is Power Aware 3D UAV placement for IoT emergency communications by the author. There's many authors.
Mr. Ahmed Bahr, I think he's the first one.
Mr. Ahmed Bahr, who presents this paper. Okay. Well,
yes.
Yes. Okay. And the others. Okay. Present. Okay.
Dr. Ahmed Bahr, yes.
Yes,
Dr. Ahmed Bahr from Manufaa University.
Okay.
Yes. There is another author in our faculty there. Like Fatah Abdel Samia, Said Rabi, Said Rabi, and Dr. Sami. This is,
yeah, you know them.
Yes, I know them well. This is our faculty. Okay, go ahead, Dr. Ahmed.
Okay, do you hear me, please?
Yes, you can start.
You can start.
You have 15 minutes and 5 minutes for discussion.
Okay, thank you.
Thank you.
First of all, this is Ahmed Bahr from Manufaa University, Faculty of Engineering, and I will present today a presentation about power-aware 3D UAV placement for IoT emergency communication. And this research is written by me and Dr. Muhassib from Misr International University, and under supervision of our professors, Dr. Sami Boulail, Dr. Said Rabi, and Dr. Fatih Said. Our agenda today is talk about UAV introduction, problem statement, system model, simulation result, and conclusion. First of all, the UAV introduction is a stand for unmanned aerial vehicles, and it is also known as drones. And due to its flexibility and mobility, it become one of the most popular research topics. UAV can be classified by altitude or by type. In altitude section, it can be high altitude platform or low altitude platform. And in type section, it can be fixed wings or rotary wings. But in our research, we consider the low altitude with rotary wings, which is suitable for our system model. Due to its flexibility also, it provides several applications like food and medical delivery, traffic monitoring, security issues. But in our research, we focus on deploy the UAV as a relay in emergency situation. The problem statement, due to wide application, it has many challenges such as channel modeling, energy limitation, path planning, and security. But 3D placement of the UAV still the key challenge due to its freedom movement, especially when UAV serving IoT devices with limited transmitted power and short distance. In our research, the 3D placement optimization is formulated taking into consideration power efficiency and the quality of service. And as shown in this figure, the minimum power losses for both ground-to-air and air-to-ground links is achieved at different UAV heights. So optimization become mandatory for this. The system model. In our system model, we assume that UAV is at height H, covering n IoT devices with different data rates in a circular covering area. The UAV acts as a relay between these IoT devices and a remote base station away from the center of the coverage area with distance D. The system model contains two path losses. The first one is ground-to-air between IoT devices and IoT and UAV. And the second one is the air-to-ground between the UAV and the remote base station. And post-links path losses can be calculated from this well-known path loss equation. Yeah. Am I go fast or it's okay?
It's okay.
Okay.
Go on.
Okay. The system model contains two path losses, as I said. The problem can be formulated as a minimum of the total transmitted power by IoT devices plus the total transmitted power by the UAV to base station. And this formula is subjected to the below constraints. The first one is guarantee that the data rate of each IoT device should be greater than the minimum requirement data rate based on its application. The second constraint guarantee that each IoT device transmit power did not exceed the minimum allowable power. The same at the third constraint, it have to guarantee the transmitted power by UEV did not exceed maximum allowable power. And finally, the remaining constraints guarantee that UEV is still in allowable height and the coverage area. This figure show the average transmitted power by IoT devices versus the UEV location, which is affected by the IoT traffic. And as shown at the optimum location, the average power decreased by 35% after optimization. To simplify our problem, we split the optimization in two stages. The first one, we used the particle swarm optimization algorithm to find the optimum planar coordinates for UV in X and Y direction. And the second one, and second stage, we optimize the UAV height itself. Stage one, using PSO, this algorithm target is to find the optimum location of the UAV in planar space by defining a set of random initial positions of the UAV fly through the 2D search space, and this location influenced by their own best past locations and their neighbors' best locations. And after each iteration, the UAV positions is updated, and after time, the positions are converged together to its optimum. Stage two, due to optimization done in the stage one, the new position of the UAV may lead to outage probability, and some IoT devices become out of coverage due to the new coordinates. And for this reason, height optimization become mandatory. We shall to change the height to increase the coverage area to decrease the outage probability. The simulation. In this section, we will present the numerical result to evaluate the performance of the PSO algorithm using these parameters, which it contain proposed cell radius, some environmental parameters, and height limitation. These figures show a circular disk represent the coverage area of the UAV with random distributed of IoT devices groups. Each group transmit with different data rate. Each figure represents a case study with different number of IoT devices. And in each case, the algorithm changes the location of the UAV, as we see, to achieve the optimum average transmitted power. This figure shows the power improvement percentage for the proposed algorithm. Offer 34% maximum power improvement, and this factor decrease if the number of deployed nodes increases. This degradation in power improvement is due to increasing power transmitted to overcome the excessive interference level caused by large number of deployed IoT devices. This figure shows the number of iteration of the PSO algorithm versus the error percentage for different number of deployed nodes. The algorithm shows high percentage of error with less than 5 iterations. But when the iteration number exceeds 20, the error percentage decreased to less than 1%. However, we recommend to utilize 10 iterations to keep minimum complexity of the process. Finally, this figure showed the outage probability versus iteration number, which reflected the good performance of the PSO algorithm, where we have only less than 0.1% outage after 20 iteration. And finally, our conclusion. This paper focused on 3D placement of the UAV to minimize the transmitted power at both air-to-ground and ground-to-air links. The proposed 3D placement method depends on the PSO algorithm. The algorithm optimizes the power for both ground-to-air and the air-to-ground links. The algorithm considers the traffic requirement of each node in 3D placement process. The proposed algorithm is implemented based on two phases. The first one is the planar placement in X and Y direction, and the second one is to optimize the altitude. The proposed algorithm achieves 34% power improvement for both IoT and UEV with an acceptable number of iteration. And finally, in the future work, we will study the trajectory optimization for moving the UEV serving mobile IoT devices. And this is our references. And thank you. I'm ready for any question if any.
Thank you. Thank you very much.
Thank you.
Okay. Dr. Ahmed, okay, go ahead.
I have two questions from, thank you, Mr. Ahmed, for your presentation. I have two questions from Professor Abu Zahed. The first one, how you can generate how can you guarantee the convergence of the optimization problem?
How can I guarantee
the convergence of the optimization?
Convergence.
Yes, we already make a simulation for more, and if we go back to these slides, we already make a lot of case studies, and we already increase the number of IoT devices in this simulation, and we got the convergence after 20 iteration for all these cases. These three curves for the three case studies, and the performance is almost the same for all of them. And this is the real simulation time.
Yes, I think that this problem is convex. That I think you will always find a solution. You will always find a solution.
Semi-quasi, yes.
You will find a position for your plane that satisfies the minimum.
Yes, if we go for this yes, this graph show it is
clear from the problem.
Yes. Yes.
This the minimum is in the more or less in the middle of your picture.
Yes, and I think there is a lot of
so yes, you have a concave, convex. It is a convex.
Yes, we can call it semi-quasi-convex. Yes.
Yes. Okay, doctor.
But I think convergence depends on the initial position. And you are using random positions as an initial positions.
Yes. This is the concept of the
welcome, Dr. Abu Zahed. Abu Zahed, welcome to this session.
Okay, thank you.
I'm happy to hear you.
Oh, thank you, Professor Abdul Halim and Professor Ayman. I am happy to see you too.
Happy to see you.
Okay.
Thank you very much for your question.
Okay, there is another question. Why he is using this type of optimization algorithms? Why you are using PSO algorithm?
Okay.
Yes, we already if we go to our references, there is a lot of papers using different algorithms, but this one show minimum number of iteration to arrive to the conversion. That is my yes.
Genetic algorithms and immune algorithms are more robust, and it can give you the results with a less number of iterations.
Okay. We can in future make another paper comparing the same problem with different algorithms. Yes.
This is good. You can make this in the future work.
Okay.
I hope so.
Thank you very much.
You can use other optimization algorithms. Yes. I have a question. Can you substitute your drone with a mast? How high is your plane? Must be situated. How high?
Well, first of all, the height is based on legal authorities. The maximum height allowable for the drones, it's already a parameter we can from the legal. In Egypt, for example, there is a limitation for the height of the.
What is
UAV.
the height? What's the height you take in your
30 meters. 30 meters. This
30 meters. Then you can make this. You can make a mast. You can make a mast. Why you use a drone? Why you use a drone?
Yes, the
you
topic
can
of
make
our
a tower. You can make a mast. You can.
Yes. The main if we go to the title of our paper, we call it emergency situation. In case of failure of any tower, the drone cover this disaster until the service come back. It is not the fixed solution. It is a recovery plan.
Yes,
for,
yes. This I think this is one this is one answer. But I think that you can shift the drone to left to right, so that you can get a most better place for the optimization.
Yes,
the must will be fixed, but your drone is mobile.
Yes, for sure. This is the
So you can get.
for sure. You
I
are
have
right.
a question. Why do you seek always all the Internet of Things sensor seek the drone? You can make a collection point on the Earth, access point on the Earth, and you can make one link to the drone, and this would be most easier.
Yes, you're already totally right. If we go now for any smart city deployed, even here in Egypt, smart new capital, or even in Alamein, there is a hotspot on smart pools, smart street lighting pools. Yes, and it's already collect all sensor result from all utilities.
Yes,
but we still but we still talk about emergency cases. If it is already allocated on a fixed pool and a car accident makes this pool drop, so and a drone can cover this area until the service come back. This is yes.
Is it really applicable? Yes, it can be. Okay, thank you very much.
You're welcome, Mr.
I have one comment regarding Professor Abdelhalim Zikri question about the height. I think the channel model you are using, there are different type of channel. There is type A, type B, type C for channel modeling for the air to ground or ground to air.
Yes.
You have to determine the height and based on the height you are using which type of a channel. It depends on the application. So if you know that your height, the maximum height, you know which type of channel modeling you are using. Okay.
Okay.
This is my first comment. I don't know if you consider it in the simulation.
I think it is a line of sight, doctor. This problem is line of sight.
Yeah, actually, they are using it with line or non-line of sight.
Line of sight.
Yes.
Because the drone in the sky.
Yes.
So there are no multiple reflections, and you seek it directly.
And the other question is, they are saying they are doing 3D placement, but I think you are optimizing the power and the height.
No,
the optimization problem.
The PSO already generates
the height is fixed.
X and Y.
The height is fixed.
So there is
no
3D.
We changed the height. No,
okay.
It's still 3D. Okay, let me.
Where is the optimization problem? If you look at the optimization problem, there is no mention for the X and Y. You are just talking about the height.
No, we already.
It's X Y يا دكتور بعد إذن حضرتك X Y طبعا. It must be X Y كمان.
Yes.
3D يعني 3D.
Yes, we already do
it is a 3D
in 2 stages. We already make a
definition
simulation
of the problem, in the definition of the problem itself, in the optimization problem.
Yes.
Which one is presenting work? I think there is a slide you are talking about the optimization problem here.
Yes, we already this slide we already as I discussed, we already make the simulation in 2 stages. The first one using the PSO to define the X and Y, and then we already define the optimized altitude separately. We in this stage we define the X and Y, and in the second stage we optimize the height.
Yes,
so
yes.
Why in 2 stages?
For simplify, not also. That's to make it easy to find the solution.
Okay.
Okay, thank you.
Halim, I have a comment.
Thank you very much. We end.
Sorry, Dr. Abdel Halim.
Excuse me. تفضل يا دكتور محمد.
I think you are assuming there is a line of sight between the drone and the other side. What about if there is an obstacle between both of them? يعني لو كان في حاجز بينهم يعني.
Yes, we can increase the height to stick still with the line of sight. Yes. I think this is maybe a
No,
solution.
you can change the channel model. You change the channel model only.
Or the
You need to
height
change
or the
the channel model. But in every case, you search for XYZ.
Yes. Okay, thank you very much.
Thank
It's
you.
okay?
Thank you, professors. Thank you.
Any other question?
Thank you, Professor Abhalim.
Thank you, Dr. Ahmed.
Thank you, friend.
Thank you all. It was very nice to meet you here and virtually. Inshallah, in the next year, we will meet face to face, inshallah.
Inshallah.
Thank you very much all, and we end the session. كل سنة وانتم طيبين. شكرين يا دكتور محمد، حضرتك معانا، متشكرين جدا.
Thank you, Professor Abdul Halim. Thank you, Professor Ayman.
نقابلكم إن شاء الله في العام القادم بإذن الله.
إن شاء الله نشوفكم على خير بإذن الله.
مع السلامة يا دكتور، تمنياتي بالتوفيق والله.
إن شاء الله.
شكرا يا فندم. Thank you very much.
متشكرين يا دكتور أحمد، جزاك الله كل خير.
شكرا يا فندم، تفضلوا مع السلامة.
مع السلامة حبيبي.
شكرا دكتور حريم. شكرا دكتور أيمن. We are moving to the second session. I know we late around 15 minutes. So we'll start with session number 3 now. The chair of the session, Professor Mawad Dusui, Professor Fathi Abdel Samia, and Dr. Mu'taz Abdul Wahab. I don't know if Professor Mawad or Professor Fathi is available. Please raise your hand. So I let the floor for Professor Mu'taz to start the session.
Good afternoon. We are going to start the session of signal, image, and video processing. I am Mu'taz Abdel Wahab from Egypt University. I would like to welcome all the audience. And we will start with, we have 4 papers in this session. The first paper is investigating speckle pattern produced by biological tissue via image quality assessment. The second paper, implementation of industrial process measurements using safe tomography techniques. The third paper, histogram processing for quality enhancement of industrial video script images. Fourth paper title is steering techniques with few number of atomic clocks, UTC NIS. I would like to, for the presenters to introduce themselves before the paper. The paper presentation is 15 minutes and 5 minutes for discussion. So please, the first paper, if it's available, please go ahead and start introducing yourself. Welcome to this session.
I am sorry.
It's okay.
I was unmuted. I am sorry. With you دعاء يوسف. كده سامعيني تمام؟
تمام مظبوط.
تمام. دعاء يوسف from the National Institute of Laser Enhanced Science, Cairo University. Today I am talking about investigating speckle pattern produced by biological tissue via image quality assessment. Outlines, speckle formation, optical setup, proposed speckle analysis, results, conclusion. Speckle is a random image, consists of bright and dark spots, appears when a diffuse object like the biological tissue is illuminated by laser radiation. When a laser beam incident on the biological tissue, the different points on the surface transmit spherical waves that interfere each other, producing the speckle image that characterized by grainy structure due to the constructive and destructive interference. Speckle is often considered in two different ways. Speckle is treated as information carrier about the surface, hence it can be characterized the biological tissue, or it can be considered as unwanted noise that distorts the images and must be eliminated. In this study, we investigate the texture properties of the speckle pattern as an information carrier through statistical analysis, from which the surface roughness of the biological tissue can be estimated. To do this work, we have two steps. The first step, we implement the optical setup to collect the speckle patterns from the biological tissue. Then speckle-based statistical analysis is proposed on the acquired speckle patterns. The optical setup, the experimental setup to capture the speckle patterns was established on 10 biological tissue samples gathered from bovine knee joints and degenerated into different average roughness values using an abrasive machines and measured to have the values ranging from 0.09 micron to 2.51 micron. The experimental setup is done using helium-ion laser with low power, nearly 1 milliwatt, and it's expanded to illuminate a cross-section area on the cartridge. Its size ranging around for the diameter nearly 2 milli. And then the backscatter radiation is collected using a ZD camera, which is put at the image plane of the imaging lens. As you see, this speckle pattern is characterized by grainy structure. The average size of these grains is related to the used speckle wave, the used laser wavelengths, and the properties of the imaging lens, such as the magnification, focal length, and diameter. Since the image quality assessment is significantly important in image processing, we used the image quality assessment known as the NIC to investigate the speckle pattern and understand how to use it to characterize the tissue. To do that, to propose our model, first the model is we implemented a learning model computed from a group of 125 natural images, undistorted images with the different sizes ranging from 400 to 128 by 720 pixels. This
Sherry?
تمام كده؟
دكتور معوض، دكتور فتحي, please mute.
معاك يا دكتور معتز.
Yes, but we can you mute the mic until the end of the presentation?
Okay.
Thank you.
I don't know where is this. We stop at which slide? At this, or I complete?
Please complete. You can complete from the last slide you share.
تمام. This is the flow chart of the proposed speckle-based analysis method. The flow chart, more details about it is in the paper. You can refer to it for details equation. In summary, we collected the images, then pre-processing step is done for the images. Then each image is divided into batches with a size defined by B by B. After that, that only the batches that have local division exceeds a certain threshold, we choose it by trying, were selected. Then a collection of statistical features, nearly 36 features, were extracted and fitted to a multivariate Gaussian model. More details in the paper. For learning, the same steps is repeated for the speckle pattern as a test image. Only all the batches were selected as we don't need to lose any sharpness or any details from the speckle pattern. So we choose all the batches. Then after fitting to the multivariate model, we have two models. We measure the distance between the two models and it returned as a distance score. As the distance is small, it returns a good quality image. The results, these are the speckle patterns that were collected from the biological tissue samples. This is the first one is the smoothest one till the last one is the roughest image. You can see that there is a variation in the speckle grain intensity, contrast, and its and accumulation. The first study for this image, you can say that the rough surface have the lowest contrast and the lowest intensity, so the image can be considered as blur and will have bad quality. Although when you have a deeper look at the images, you can see that the speckle which acquired from the smooth surface have the smallest grain size and the image have many gray level transitions and can be considered and random, so it can be the most noisy than the rough image. And this assumption, what I discussed, and this assumption were valid by when we drew the D against the average surface roughness. We can see that this is the most smooth image, which have the lowest, the higher D than the best, the lowest quality. Although the last is the roughness, the image with large roughness have the good quality, the best quality. To validate this assumption, the local entropy image which describes the randomness of speckle pattern was calculated and plotted in this graph. You can see that the first image has the highest local entropy, which means that it's the most random image and the more noisy image. And as the surface roughness increase, the brightness decrease, and the uniformity means that the image become more uniform. And this validates our assumption. In conclusion, investigating the image quality of speckle pattern produced by bovine cartilage samples through the natural image quality evaluator provide good evaluation methods that can help to understand and investigate the texture properties of the speckle pattern. The analysis of the speckle pattern using the natural image quality give acceptable results, but it can't be used for differentiating for precise calculation. However, it helps us to understand the quality of the image, how to treat it using second order or higher order statistics that will yield better and precise differentiation for the biological samples. Thank you.
Thank you very much for your presentation. I would like to welcome Professor Maawad Dsuki from Monofaya University and Professor Fathi Abdessamia from Monofaya University and Professor Hanaa Shakir from JAC-ECC University for chairing this session. And please, we would like to open this session for discussion. So please go ahead, professors, taking the lead.
Yes, Dr. Mu'taz, you hear me? Dr. Mu'taz?
Yes, I hear you very well, Professor.
Okay.
Please go ahead. Thank you.
The first question is, figure 1, she say this is a flow chart, but this is not flow chart. This is just the steps of the algorithm.
Yes, it's the steps.
Okay.
Okay.
Second questions, what is the meaning of image quality in terms of speckle pattern? What do you mean?
Image quality means the image have more noisy or more uniform. Can you?
We know that, but you didn't measure parametric value to indicate the image quality improvement or image quality goodness for something like that.
No, the distance D is the quality metric. This is the quality metric.
Okay.
And this figure represents the quality metric for the speckle images.
Then how the improvement is? There is a numerical value for the improvement value in image quality?
In this paper, I just study and investigate the speckle pattern. I don't differentiate. I want to prove that the best statistics that can differentiate and use to evaluate the tissue using speckle must depend on higher order statistics or second order, not on just intensity or contrast like most of literature do. Yeah, most in literature you can see that only uses the contrast and the intensity to differentiate between the results. However, if they use higher order statistics, it will give a good discrimination.
Which higher order statistics you used? Third order or fourth order?
In this paper, this metrics depend on second order.
Second order, but second order, not higher order statistics.
No, not higher order. At least you begin at second order or higher, not only on the intensity or contrast.
Okay. But you should add something related to other work and give a good comparison between your work and
I will do this for future work, really.
Okay. Thank you. Thank you, Dr. Mu'taz.
Thank you, Doctor. Any other question from professors? Professor Hannah?
Thanks for the nice presentation. I have only one question. You said that the local deviation value is chosen as 0.75. How did you choose this value?
This is a threshold. I choose it by trying. This give me the best. Finally, using this threshold, I have the best local diffusion batching. It's only a step.
Yes, just trial and error.
Yes.
Okay.
Okay, Professor Fathi, do you have any question?
Okay, no questions.
Thank you.
Thank you.
Thank you.
Thank you.
So our next paper is implementation of industrial process measurements using safe tomography techniques. So for the presenter, please introduce yourself.
الصوت مسموع بس انا مش واخد بالي الصوت مسموع ولا ايه؟
الصوت مسموع كويس.
تمام شير بس تمام. تمام كده يا فندم نبدا ان شاء الله.
تمام اتفضل.
At first, I will to introduce myself. I am Samir Al-Amriti from Monofia University Faculty of Electronic Engineering, Department of Computer Science and Engineering. I will introduce today my research is implementation of industrial process measurement using safe tomography techniques by me. The group are worked in this work are Prof. Dr. Nabil Ismail, Faculty of Electronic Engineering in Monofia University, Prof. Dr. Muhammad Badawi, Faculty of Electronic Engineering in Monofia University, and me, Samir Al-Amriti, Faculty of Electronic Engineering in Monofia University. My topics are introduction and the problem definition and the proposed system overview, results and conclusion and future works. Introduction, I will introduce the EIT science. What is the EIT? EIT is a novel industrial imaging technique that can be applied to visualize changes of impedance within a pipeline to measure flow velocity. What is the EIT system's advantages? Number one is low cost in maintenance. Number two is simple installation, fast imaging speed technique, high sensitivity to functional changes in the industrial process, and high temporal resolution. The first one is low cost in maintenance because the system is simple, and the spare parts of this system is just electrodes to be erected on the boundary of pipeline. This is a simple installation, and this is a fast imaging speed technique. Comparing to the other techniques, and high sensitivity to functional changes in the chemical process in the pipeline, and high temporal resolution comparing to the other techniques. And there is no hazard radiation because he is a safe technique comparing to radioactive, comparing to MRI and X-ray, gamma ray, beta ray, and something like that. EIT systems have two techniques. 2D EIT. 2D EIT is called the most traditional application. Use the 2D EIT system. This is one ring of electrodes erected on the boundary of the pipeline, but this is a one ring, as shown in figures. But the 2D EIT systems have disadvantages, such as limited information, because this is a one ring of electrodes and the measurements is low. The measurements is low and lacks to image volumetric, because this is a 2D, not 3D. And low resolution because the measurements is low. Another technique is 3D EIT. Most new applications of EIT have placed electrodes in 3D rings around the tested item. And the 3D EIT systems have advantages: high sensitivity, and used to image volumetric because this is a 3D, and high resolution because the more of measurements that obtained from the system, as shown in figures. EIT flowchart. The EIT systems flowchart, as shown in figure, it divided to forward model. We suppose the conductivity of the system, and we will inject a small current in the pipeline, in the electrode, pair of electrodes, and obtain the voltages from all the adjacent electrodes. After that, this is a forward model. After that, we compare the voltages obtained to the real voltage obtained in the real system. After that, we obtain the real conductivity. This is an inverse model, inverse solution. After that, the inverse solution, after sum of calculates, go to image reconstruction unit. After that, the image is deduced from the system. About the reconstruction stage, EDORS with NetGen framework generate 3D meshes as a simulation of pipeline. After that, software program to generate the mesh structure file. The software produce mesh file.dat. After that, one step GN algorithm. This is the inverse model that I used in this work. After that, the MATLAB with EDORS produce an image. The problem definition, the most common application of two-dimensional and three-dimensional EIT measurements in the industry are the pipeline flow measurement techniques, such as flow velocity. We can obtain the flow velocity by two principles. The main principle of the flow velocity measurement is in this work implemented by two methods. The first method is voxel to voxel autocorrelation of images with highest value of the correlation coefficient. Voxel is the volume element, and the cross correlation between images when it's reached to the highest value of the correlation coefficient. After that, the time delay of peak value of the correlation coefficient function which indicate the flow transit time between the stream sensors plane. The research objectives. What is the objectives of research? To develop a new sensing strategy to match with 3D nature in pipeline flow. To develop a 3D EIT image reconstruction algorithm for the new sensing strategy. To implement the forward and inverse solution with the aid of 3D mesh generator and EDORS framework respectively. To evaluate the rapid response and high performance of the new sensing strategy. 3D visualization algorithm using EDORS framework.
5 minutes are remaining.
Yes. To investigate the method of flow velocity extraction based on information obtained with the new sensor configuration and algorithms. Research importance. This research is introduced a new sensing configuration of three-dimensional EIT industrial proposed system to measure the pipeline flow velocity. The flow velocity is calculating method. This our system is considered as 4 rings, 2 upstream rings and 2 downstream rings, and the flow is moved from the upstream to downstream. With the EIT, with the time transit, we can calculate the method, the velocity. This is as built in the real time. We want to introduce that. Our system is a chemical process. After that, 3D EIT sensing strategy. After that, data collection system. Once after that, the one step Gaussian Newton reconstruction algorithm, 3D volume image cross correlation with time delay. After that, the velocity is calculated. Yes, the architecture of the system, the proposed system is constructed of a 64 electrode system, 2 planes, 32 electrode per plane, sensing each plane has 2 rings with 16 electrode per ring. The algorithm is used forward solver FEM finite element method. This is the famous algorithm to consider the potential distribution of voltage boundary of the pipeline. The inverse solver is Gauss-Newton solver, one step Gauss-Newton solver. Yes, this is the system, upstream and downstream planes. We put a Teflon ball on the homogeneous. The first one is homogeneous. The second one is the Teflon ball. Teflon ball is put in the pipeline. This is the reconstructed images from images where the ball moves from z equal 90 and equal 0.9 to z equal 0.1. This is the results of the correlation coefficient. When I compare to the related works, this is the results of the corrected the comparison compared with 32 electrodes, 2 planes and 2 rings, and this is the mathematical method of velocity. The correction function applied to volume images is defined as by this equation, volume 1 and volume 2, voxel window 1 and voxel window 2. And after moving the ball by alpha and beta and gamma, this is the equation of summation of the moves. About the results, we can obtain the highest value of correlation coefficient of our system to 0.9982. This occurred when the ball on the height of 0.9 and 0.2. The conclusion: we used sensing plans with 64 electrodes with a system with moving ball model forward by thresholding 2D correlation coefficient algorithm to measure the flow velocity. We have used a one-step Gauss-Newton solver algorithm algorithm approach can reconstruct EIT images with more accuracy than the many approaches, as well as a high improvement of 2D correlation coefficient between views. Our approach can replace more complex and slower iterative approaches. Moreover, once the system which used the one-step Gas-Newton solver algorithm approach is achieved, it can reconstruct EIT in nearly real-time movement monitoring. The future work is increasing the accuracy of velocity calculation and flow regime assessment. We have the assessment of flow as turbulent, as laminar. Enhanced EIT imaging resolution, electrode position, and the electrode position is affected on the images, the accuracy of images, and the resolution. Thank you.
Thank you very much for your presentation. We'll open the panel for questions.
I have two questions, please. The first one, could you please indicate the basic idea of the 3D EIT image reconstruction algorithm employed in your work? I think you didn't highlight the idea.
Yes. Can I answer?
Yes.
My algorithm is famous, and research. Many researchers work with it because he is high accuracy and he is low computation time. This is affect on the speed of the system. Yes.
What are the main differences between this reconstruction algorithm and other reconstruction and other image reconstruction algorithms?
The 3D algorithm is worked with voxel to voxel, because 3D 3D algorithm is worked with volume element of the pipeline. Yes.
Yes, I got it.
Okay.
Yes, speak. Worked with a voxel element of the pipeline in the simulation of the pipeline. Work with voxel, and the other algorithms is worked with pixel to pixel.
Dr. Mu'taz?
Please, Professor Maud, go ahead.
Okay, I have three questions, please.
Yes.
The same problem or the same mistakes for this author or the previous author. This is not flow chart. Again, this is a block diagram. The author should know what is the difference between the block diagram and the flow chart. This is one. Second one, he says new strategy. Why he says new strategy?
Yes. About the new strategy, because the old systems used two electrode, two plane.
Okay, but the same idea is the same, but the main difference, the old or the previous work used two electrodes and you use 64. Then
yes, 64 divided on 4 rings.
You should call the proposed approach.
Yes.
The third question is, you say the correlation coefficient is become about 0.998.
Yes.
What is the improvement of the value of the correlation coefficient?
The improvement?
Yes. For 2 electrodes, the correlation coefficient is what? And for using the 64 electrodes, the correlation coefficient become what? Then you should compare between these two values and compute the improvement in the correlation coefficient. And what is the effect of this improvement of correlation coefficient on flow velocity?
Yes, I compared the old systems with 32 electrodes, 2 planes,
yes,
and 2 rings in this table.
Yes,
yes.
In the table. It is shown in the table. But you should indicate with the result discussion the improvement which at certain distance value for correlation coefficient, and what is the effect of this for flow velocity?
Yes, the effect on flow velocity is when the resolution of when the resolution of the images is high, the correlation coefficient is high. After the correlation coefficient is high, all the calculation after that with time.
Oh, okay, the last question is, you didn't give any discussion about the complexity analysis when using 64 electrodes as compared to using 2 electrodes.
The comparison is in this table.
No, I mean the complexity analysis.
Yes.
Okay, put it in the future work. No problem. No problem.
Okay. Thank you.
Okay. Thank you, Professor Mu'taz. Thank you.
Thanks, Professor. We will go for our next presentation, histogram processing for quality enhancement of industrial video scope images. So for the presenter, please introduce yourself and share the presentation.
Okay.
Thank you, my professors. Thank you, my professors.
الصوت واصل كده؟
تمام، الصوت واصل.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Histogram for quality enhancement of industrial video scope images, presented by engineer advised by Professor Atif Abul Azm and Professor Fatih Abdel Sami and Dr. Amir Al-Safrawi and Dr. Walid Al-Shafi and Dr. Huda Sheikh. Outlines of the paper.
ممكن حضرتك تعلي الصوت شوية؟
Paper objective, background, introduction, related work, proposed approach, experimental results, and conclusion. Paper objective. The main problem of the video scope image suffer from noise and low contrast and weak edges. And the paper objective is improving the visibility of low image contrast and decreasing the noise and improving edge details and edge detection. Background. The industrial video scope device designed for inspection of professional equipment like motors, turbines, and cavities in buildings and vehicle bodies. The inspection process is performed during the operation of the equipment. The video scope device gives different outputs such as images and videos. Introduction. This paper presented an efficient approach for video scope image enhancement, namely contrast limited adaptive histogram equalization with adaptive gamma. It enhances the features of video scope images and addresses the sources of deterioration in the captured images. During the acquisition process, illumination, variations, and motion affect the captured image quality. Related work. This section presented a short review for earlier studies to enhance images that suffer from problems. Most studies cover histogram equalization and histogram matching and homomorphic enhancement. A. Histogram equalization. Histogram is graphical distribution of pixel over intensity, and histogram equalization is the process to modify the histogram of the image with low contrast to be uniformly distributed rather than being concentrated in a certain band of levels. It is performed based on the cumulative distribution function of the image. B. Histogram matching is the process to correcting the low contrast image histogram according to the histogram of a high contrast image which is better distributed. This is accomplished through the modification of the global mean and variance of the image with poor histogram to yield an image with better histogram. Enhancement. Video scope image is composed by multiplication of illumination and reflectance components. The illumination is approximately constant, while the reflectance contains most image details. Both components are separated through a logarithmic operation. Hence, the illumination component is attenuated while the reflectance component is magnified. After this process, the image is reconstructed with better quality. Proposed approach. It is based on contrast limited adaptive histogram equalization with adaptive gamma correction. The basic idea of the contrast limited adaptive histogram equalization technique is to segment the image into blocks and work on blocks separately to match the image local activity level variations. The main purpose of clipping limit is eliminating possible magnification of noise beyond a certain limit and also eliminates block artifacts. A clipping limit beta that is estimated as follows: equation of clip limit beta and the equation of gamma correction presented. The proposed approach is based on a clip limit to avoid magnifying the elimination effect. Applying gamma correction is intended to increase the dynamic range of the image in order to correct both lightness and darkness problems. By specifying an appropriate clip limit in contrast limited adaptive histogram equalization and the value of gamma correction, the proposed approach achieves noticeable contrast enhancement of the video scope images. Flowchart of the video scope image enhancement based on a proposed approach. Apply contrast limited adaptive histogram equalization to input video scope image with initial value of beta and evaluate quality metrics. Are quality metrics the best or no? Yes or no? If no, update value of beta again. If yes, apply gamma correction on the output of videos of contrast limited adaptive histogram equalization image with initial value of gamma and evaluate quality metrics. Are quality metrics based? Yes or no? If no, update gamma correction. If yes, we get output video scope image. Experimental results. We have performed 2 experiments on images for a part of turbine blade of a gas unit in a power station with different size. Such an enhancement can be assisted subjectively by visual inspection of the image as shown in figure 3G and figure 4G. Visual inspection emphasizes that a great enhancement is obtained compared to figure 3 and figure 4. Figure 3, results of the video scope experiment 1. The figure 4, results of the video scope image experiment 2. From figure 3 and figure 4, the proposed approach achieves better contrast enhancement and enhances the features of the video scope image. Table 1, numerical results of the video scope image 1. Quality matrices are entropy and average gradient and contrast enhancement factor and edge magnitude. And table 2, numerical results of the video scope image 2. From the numerical results listed in table 1 and table 2, it's clear that the proposed approach achieves better entropy than the previous works and detects weak edges and correct both lightness and darkness problems. And the proposed approach achieves noticeable contrast enhancement of the video scope images. The spectral entropy is estimated from the normalized discrete cosine transform coefficients. Figure 5 and figure 6 give probability density functions of the entropy estimated over blocks in the discrete cosine transform domain. The spread of the curve reflects the spread in the spectral content of the images. From the two curves of the original and enhanced images, we notice the better spectral content of the enhanced image. Figure 5, spectral entropy of the original and video scope image 1. And figure 6, spectral entropy of the original and video scope image 2. Conclusion. This paper investigated the problem of low contrast video scope images acquired through the maintenance process of power stations and contrast limited adaptive histogram equalization and gamma correction has been presented. Simulation results prove that the proposed approach is superior to traditional image enhancement techniques from the quality metrics perspectives, and the proposed approach can be effectively implemented in non-destructive testing applications that depend on image processing in poor conditions. Thank you.
Thank you very much for your presentation. We'll open the session for questions. I have a question. The number of tested image is very few. Why didn't you try on more samples? This is number one. And could you please go back to the tables and show the more detailed the enhancement in the numbers according to different methods?
Table 1 and table 2, the numerical results of the video scope image 1. The proposed approach is the last value. Achieve the best of the quality metrics, entropy and average gradient and contrast enhancement factor and edge magnitude from the traditional images. And from figure 3 and figure 4 is a visual image is best enhancement from the traditional or previous works.
So why you applied only a few number of images?
The available images are low, are few. From the real video scope image device.
Okay.
I have a comment, please.
Yes, please.
The clip limit employed in your work may lead to loss, to information loss, I think. You should use a suitable assessment metric to measure information loss. You should also compare with other enhancement techniques to see if contrast limited adaptive histogram equalization is an enhancement technique which minimize the information loss, or there are any other enhancement techniques which work better.
The proposed approach consists of the two stages. The first stage, the contrast limited adaptive histogram equalization, and the second stage is gamma correction technique. Two stages used to optimize contrast enhancement and the visual image by try the program the selection value of beta and gamma are done by running the program many times with different values to obtain the optimum value of beta and gamma, and we selected the value of beta 0.1 and the value of gamma 1.3. To optimization the value of the image 1 and the image 2, enhancement of the image 1 and the image 2.
Okay, what I meant that we couldn't depend only on subjective evaluation in evaluating our proposed on evaluating your proposed algorithm. You can use some assessment metrics such as visual information fidelity. This metric tells you how much information was lost during enhancement in your technique. You can put this as one of your future directions.
Okay. We could consider this question in future.
Thank you. Thank you.
Any other questions?
I have some more questions. The difference between flash only and the gamma correction, flash with gamma correction. The author should mention some of the difference between using flash only or flash with gamma correction to see the improvement using this combination. The second question is, what is the importance of this metric parameter for measuring the improvement of image quality? The third one is, this is a good method used for low contrast image, or there is another method? The fourth question is the complexity analysis when using the combination between flash and the gamma correction. Okay, this is
the proposed approach is the best from the visual image and subjectively metrics based on the figure 3 and figure 4 and table 1 and table 2.
Okay, thank you. Okay, thank you, Dr. Marquez.
Thank you. Did you, any other questions? So thank you. Our next paper will be steering techniques with few numbers of 8 atomic clocks UTC NIS. Dr. Ali Mustafa. Please introduce yourself and share the screen with the session.
Excuse me.
We can hear you well now.
Okay. Can you see my presentation now?
Not yet.
No?
Not yet.
Okay.
You need to share the screen. Yes, I can see you now.
How can I share the screen?
Down, you can say share screen at the bottom. The green arrow.
Can you see it now?
Not yet. On your screen, there is a bottom arrow, share screen, green.
Wait, please. Can you see it now?
No. Oh.
Dr. Ali, you have to share the screen. You have to share the screen from the bottom and then select which one you are going to select. You may make share screen and then whole screen. The first choice.
Please wait.
Okay. Oh. I can show you a quick example. For example, I will share my screen.
Please wait for.
Take your time.
You see it now?
Yes, we are seeing your screen. Can you go to the presentation and make it in a slideshow?
Can you see the presentation now?
Perfect. Thank you.
Thank you very much.
Thank you, Doctor.
Go
ahead. You have 15 minutes and 5 minutes question. Thank you.
Okay. Yeah, I'm Ali Mustafa. I'm working as a researcher at the Time and Frequency Lab of the National Institute of Standards in East Egypt. I am the corresponding author of paper number 21, UTC NIS steering techniques with few number of atomic clocks, by me, Ali Mustafa, and Professor Dr. Abdel Halim Zikri from Ain Shams University. Outlines: I'll give an introduction, motivation, and the contribution of the paper, average atomic time scale of NIS, TA of NIS, results from TA NIS simulation, current UTC NIS steering techniques, UTC steering by using GPS time scale as a reference, UTC NIS steering by using UTCR as a reference, then conclusion and the future work. What is a time scale? A time scale is the force coordinate of the four dimensional space-time reference system. The coordinated universal time is the international reference time scale with the best accuracy and the long-term stability characteristics by which the world regulates clocks and time. UTC is defined by ITU-R and is determined by the International Bureau of Weights and Measures, BIBM of Paris, France, in cooperation with the International Earth Reference and Rotation Service, IERS. Process of UTC generation at BIBM. First, BIBM collects the comparison results of atomic clocks around the world, more than 350 atomic clocks. Then, using an average algorithm, the BIBM calculates each atomic labor or free atomic time scale with a stability 0.4 multiplied by 10 raised to -15 at 30 to 40 days. Then by a steering algorithm, the BIBM steers the frequency of the free atomic time scale to the primary frequency standard maintained at 8 labs around the world. The resultant is international atomic time. Then by the insertion of the leap second, in cooperation with the measurement of Earth rotation service, IERS, the result is the UTC, which is the international reference time scale, which is disseminated to participating labs in the form of UTC minus UTC of K, the circular T results every month, which is the feedback provided to timekeeping labs around the world at the end of the month. After that, unfortunately, UTC is not a real-time time scale, but it's a paper version that is calculated using a post process. So every timekeeping lab around the world maintain and compute its real-time scale, which is UTC of K, which is the real-time version of UTC, and is maintained by time labs, and it is used in the daily applications. UTC of K can be used as a traceable reference for all the time dissemination and calibration services introduced by timekeepers. The required characteristics of the real-time time scale UTC of K, where K is the timekeeping lab around the world. UTC of K time scale must has some features: immediate access, high reliability, high stability, high accuracy, such that the time difference between the international reference time scale and the local version time scale at the lab should be kept smaller than 100 nanosecond, as recommended by the CCTF at BIBM, which is the International Consultative Committee of Time and Frequency around the world. There are two techniques for achieving these characteristics. Achieving high reliability and stability for UTC or UTC of K time scale require an ensemble of atomic clocks, and the generated time scale is simply the weighted average. This is known as the time scale algorithm. As the number of quality stability of the clocks in the ensemble increase, the stability of the resultant time scale improve. The second one, the accuracy of UTC of K time scale can be improved by applying different steering schemes based on primary frequency standard, or on the difference between UTC minus UTC of K or its rapid version, or the output of the weighted average algorithm built inside the lab, or a combination of all of them. So these are the steering algorithms that are used for improving the time accuracy of the time scale with respect to the international reference time scale, and the time scale algorithm improves the frequency stability of the local time scale with respect to the international reference time scale. The main requirements for establishing and maintaining a UTC of K time scale within a timekeeping lab: atomic clocks. There must be an ensemble of atomic clocks within the timekeeping lab with different levels of frequency stability, such as hydrogen maser, cesium clocks, cesium fountains. After that, the second stage is the time scale generation system, which consists of the time scale algorithm and the steering algorithm for improving the frequency stability and the time accuracy of the resultant time scale. After that, the time scale generated at the timekeeping lab, which is UTC of K, is transferred to BIBM for the international time scale difference comparison, to provide the feedback at the end of the month to use these results for UTC of K steering. This block diagram explains more the process of generating UTC time scale at a timekeeping lab. First of all, the ensemble of atomic clocks within the lab. The time difference between clocks is calculated by a time interval counter. After that, the time scale difference, or the phase difference between clocks, is used within the time scale algorithm to produce the ensemble atomic time scale, which is used for the frequency steering of the resultant time scale. Then This time scale is transferred to BIBM for the time scale difference comparison, so that the difference UTC minus UTC of K is kept within 100 nanosecond as recommended by the international CCTF within the BIBM. After that, we are the time scale steering algorithms may be built upon the average time scale generated within the lab or the result of the circular T, which is UTC minus UTC of K, or using the primary frequency standard within the lab if the lab has a primary frequency standard, or predicting the offset of each atomic clock from each UTC using Kalman filter and then computing frequency steering values from the weighted average of these predictions. So these are the time scale steering algorithms that can be used within a timekeeping lab to improve the time accuracy of the result of the time scale with respect to the international reference time. But unfortunately, the use of any of these time scale steering algorithms within the lab depends on the available resources within the lab. If the lab does not have an ensemble of atomic clocks, so it cannot use the first approach for steering. Also, if the lab does not have a primary frequency standard, it cannot use this approach for steering each time scale. So the remaining two approaches that can be used within the lab, if the lab has only 1 or 2 cesium atomic clocks, it can use the results published by the BIBM every month for steering. So this is the only approach that can be used for steering in that case. For the paper motivation and contribution, we are talking about the available resources at our lab. We have 3 cesium atomic clocks, but one of them was installed at the lab at 2005, and the second one was installed at the lab in 2018, and the third one was installed in the lab 2019. So we at our lab now we have 3 cesium atomic clocks with the clock comparison system and our time transfer system. So these are the available resources at our time and the frequency lab. Our NIS atomic clock ensemble in the current time consists of 3 high performance cesium atomic clocks. The code of the first one is 135 to 182, which was installed in 2005. The second one 36454 installed 2018. Which is the NIS master clock in the current time. The last one 3812, which was installed at 2019. So now we have 3 cesium atomic clocks at our lab, but the frequency stability of these atomic clocks are different because they were installed at different times at our lab. And this is our clock comparison system at NIS, 3 cesium atomic clocks and a switching matrix to compare each cesium atomic clock with the input of the time interval counter, which has 2 channels. Channel A input is the UTC of NIS. Channel B is one of the 3 cesium atomic clocks. So the comparison result of this system is UTC NIS minus cesium 1, UTC NIS minus cesium 2, UTC NIS minus cesium 3, and these comparison results are uploaded to BIBM for the calculation, for the participation in the computation of the International Atomic Time Scale. This is the time scale algorithm used at our lab for the generation of T of NIS. The average atomic time scale is defined as the weighted average of the difference between the measured minus predicted value of each clock with the prediction of the clock equation and with the weight of each clock according to its frequency stability. So this is the time scale algorithm which was presented at our previous work and used in this paper for the validation of using our average atomic time scale for using it for the steer of our local time scale UTC of NIS. So using this time scale algorithm and using the comparison results of our atomic clocks, we compute our average atomic time scale of the National Institute of Standards. We use the comparison results for 293 days using the 3 atomic clocks at our lab with the code of each clock as shown in this slide. and these are the results: the frequency stability of the 3 cesium atomic clocks and the resultant average time scale. Sorry, we use only 2 cesium atomic clocks for building our average time scale, because the third one is the master clock, and we compute the difference between each clock of the ensemble and the master clock, and use the phase difference values or the time difference values between the clocks and the time scale algorithm. So the time scale, the average atomic time scale TA of NIS is generated from 2 cesium atomic clocks only. And this is the frequency stability of the 2 cesium atomic clocks by using the rapid version of the international reference time scale as a reference. This is the frequency stability of the first cesium atomic clock, and this is the frequency stability of the second atomic clock, and the blue curve is the frequency stability of the resultant average time scale. From this curve, we note that the frequency stability of the resultant average time scale is nearly the same as the frequency stability of cesium 3812, and this stability is bad as compared to cesium 2182 because due to strong correlation between the resultant average atomic time scale and the clock that has the best frequency stability among the two clocks. Building the average time scale of NIS using only 2 atomic clocks with a large difference between the stability of the 2 clocks results a time scale that has nearly the frequency stability as the cesium atomic clock with the better frequency stability. So this average time scale cannot be used for steering UTC of NIS, because the main goal of building an average time scale is to produce a time scale that has a frequency stability better than any contributing clock in the ensemble. So building an average time scale using only 2 cesium atomic clocks with large difference in stability between both of them results a time scale that nearly has the stability as one of the 2 clocks, which has better frequency stability than the other. So this time scale cannot be used as a steering strategy for our time scale UTC of NIS. So in this paper, we validated that TA of NIS, that building TA of NIS using only 2 cesium atomic clocks results a reference time scale that cannot be used for steering in that case. So we used other techniques for steering our time scale to improve its time accuracy with respect to the international reference time scale. And the second goal of this paper is current UTC NIS steering techniques instead of the average atomic time scale. These are the 2 devices that are used now for our time scale steering: a single cesium atomic clock, which was installed at NIS at 2018, and the frequency of the generator to adjust the frequency of this cesium atomic clock. The output of this auxiliary output generator is the time scale of the National Institute of Standards UTC of NIS, which is the national time scale of Egypt. This is the UTC minus UTC NIS results over around 2 years from 1 January of 2015 to 21 of February 2017, over around 2 years. This is the status before we steer our time scale using the methods in this paper. The difference between UTC minus UTC of NIS was between 4,000 nanosecond and minus 8,000 nanosecond, which is the recommendation of the CCTF. So there must a steering algorithm for steering our time scale to full UTC of NIS. These results are published by BIBM every month, and from these results I can check the effectiveness of my steering algorithm. For the first steering algorithm, we use GPS minus UTC NIS data, which is generated by a time transfer system at our lab. So we collect this data for successive 5 days and plot this data and estimate the slope of this data and use this slope for the frequency steering of our time scale. This is the first time scale steering algorithm. The second technique use UTC of R minus cesium 3654, which is our master clock, for calculating the frequency steering value that must be applied to the auxiliary output generator for the frequency steering of our time scale. We plot this time difference data and calculate the slope of this data and use this slope for the frequency steering of our time scale. After we applied these two steering
1 minute
algorithms
left.
Okay. After we applied these two steering algorithms for our time scale, these are the time scale difference values for the last 3 years. From these results that are published by IBM, we found that the time accuracy between our time scale and the international time scale was largely improved as compared to the previous curve. It was between 50 and minus 50 nanosecond, except for two accidents due to the failure of our transfer equipment at the lab. And this is the steering results of our time scale in the last 1.5 years. Results show that our time scale difference values were between 50 and minus 40 nanosecond. So the two time scale steering algorithms was effective for steering our time scale towards the international reference time. So now we can keep the difference between UTC and UTC of NIS within 50 nanosecond. The conclusion: building a time scale with only two cesium atomic clocks cannot be used for the time scale steering. Also, by these two steering algorithms, we can keep the difference between our time scale and the international reference time scale within 50 nanosecond and obey the recommendation of the CCTF. In the future, we will increase the atomic clocks of our ensemble to at least 3 and build the average time scale algorithm and generate TA of NIS and use it for steering our time scale. As the second steering strategy with the two steering strategies presented in this paper, and study the possibility of using empirical mode decomposition for the prediction of our atomic clock and use EMD as a third steering strategy for our time scale. Thank you.
Thank you for your presentation. Open the session for questions.
I'm ready.
Thanks for the presentation. I want to know, please, what are the main challenges you faced during your experimental work in the laboratory, and how did you face these challenges?
Okay, please wait a minute to the many challenges within our lab that we have only 3 cesium atomic clocks at our lab in the current time. One of them was installed at 2005, so its stability now is bad. So when we build the time scale algorithm with these 2 clocks, this is the master clock now. It is not used in the time scale algorithm because we use the time scale difference values in the algorithm. So we use the difference between between cesium 1 and cesium 2 and cesium 1 and cesium 3 in the time scale algorithm. So in the time scale algorithm, we have only 2 cesium atomic clocks. One of them was installed in 2005, and this stability is bad as compared to the other clock. So the resultant time scale, as shown in this curve, has a stability which is nearly the stability of the clock that has better stability than the bad one. So at our timekeeping lab now, we have only 2 cesium atomic clocks with a large difference between its stability, so the resultant average time scale the major problem clocks, because the cost of maintaining is $2.25 million every 5 years. So we will buy I think the cesium atomic clocks in the few days, and add to our clock ensemble to build the TA of NIS using 3 cesium atomic clocks to produce an average time scale which has a stability better than any contributing clock of the ensemble to use it for UDC NIS steering.
Thanks.
You understand me?
Yes, thank you.
So the major problem at our lab now is the lack of cesium atomic clocks because its cost is very high.
Okay, I have another question, please. Your future directions include increasing the number of clocks. According to your according to your expectations, what will be the effect of increasing the number of clocks?
The effect, the frequency stability of the resultant average time scale depends on the number and the quality of atomic clocks in the ensemble. So we expect that by increasing the number of atomic clocks in the ensemble, the frequency stability of TA of NIS will be improved, so that it is fold under this curve here. With a frequency stability that is better than the stability of the contributing clocks in the ensemble. So if the average time scale frequency stability is located here, its frequency stability is improved and is better than the clocks of the ensemble, and I can use it for the frequency steering of our time scale in the real time.
Okay, what about the drawbacks?
There is no drawbacks for increasing the number of atomic clocks, other than its cost. The cost of cesium atomic clocks is high. Yes. So I will depend on some signal processing techniques that we presented at our previous work, like empirical mode decomposition, like using Kalman filter for improving the frequency stability of TA of NIS.
Yes, to achieve a balance between frequency stability and minimum cost or suitable cost.
Yeah, you are right. The minimum we will achieve the minimum number of atomic clocks in the ensemble, which is 3, and we will build our TA of NIS using 3 cesium atomic clocks, and I will apply this signal processing techniques on the resultant TA of NIS to increase or to enhance its frequency stability a bit larger, and use it for UDC NIS steering. But at the time of this experiment, I built the TA of NIS using 2 cesium atomic clocks, and the frequency stability difference between them was large. So the frequency stability of TA of NIS was nearly the same of cesium 3812. So there was no benefit from building TA of NIS using only 2 cesium atomic clocks.
Thank you, and I wish you all success.
Okay, thank you very much.
Thank you, Professor Hannah. Thank you, Professor Moawad. Thank you, Professor Fathi. It was our great pleasure for you joining us today for this session. We're looking forward for meeting you. For all the audience, I have a small announcement by Dr. Ahmed, please.
Okay, thank you to Professor Moataz for sharing this session with Professor Hannah and Professor Moawad and Professor Fathi. We have some technical problem today morning with Professor Ahmed Al-Wakil lecture. So we have a compensation tomorrow at 1:30. The presentation or the keynote speech of Professor Ahmed Al-Wakil will be compensated tomorrow at 1:30 p.m. For 45 minutes at the same room, virtual room 1. So I want to pay your attention for this keynote speech. This is the end of our broadcasting today for the virtual JAC-ECC 2020. Wish you all have a good night and see you tomorrow morning at 10 a.m. Thank you.
Thank you.